Rational functions. We can take any rational function, and remember, first of all, the reason it's called a rational function is because it's simply a ratio of two polynomials. The numerator we call n of x, usually just like when we're talking about it, and d of x. And the thing to remember is that they're very different roles. The denominator can basically cause trouble, right? Because it can't be equal to 0 or else it's causing trouble, right? And that's where we get the domain from. So the denominator, x minus 2, cannot be equal to 0. You can't say x not equal to 0. That's nonsense. You can say x minus 2 not equal to 0. And that gives us x not equal to 2. So that's our domain. And the cool thing there is the vertical asymptote and domain go together. So you have 2 for 1 almost here. The vertical asymptote, as x gets closer and closer to 2, we know it can't actually take on the value of 2 because you can't make sense of it. But we'll just say x equals 2 because there's basically a vertical asymptote where the function will blow up or blow down, as I say, down deep to negative infinity or up to positive infinity. So the domain is x not equal to 2. The asymptote, the vertical asymptote, is x equals 2. X-intercept, now remember, that's just what? Y equals 0. That's the x-axis. Well, how do you get y equals 0 here? Well, with this one, you can't. The denominator can never get y equal to 0 because you know, it's the numerator that matters. Well, 3 is not equal to 0, so you say there's no x-intercept. Y being, of course, the output. Y-intercept is when x equals 0. Well, we know how to plug in when x equals 0. It's just f of 0. So the y-intercept is the same as with polynomials. You plug in x equals 0. You get 3 over 0 minus 2, which is simply 3 over, remember, if you just have 0 minus 2, you have negative 3 halves. The negative sign can be anywhere you want to put it there. You can put it up here. It's just the negative 1. There's that, negative 3 halves as your y-intercept, but you really should write it as a point to be rigorous, but we get it. Now the horizontal asymptote, remember, there's 3 possibilities. The degree of the numerator, okay, greater than degree of denominator. It's the degree we're talking about. Remember that from polynomials we just did? It's the highest power. All you care about, because really it's end behavior. End behavior only cares about the highest power, which is the degree of the whole polynomial. If it's greater than, that means the numerator, there's no horizontal asymptote. Okay? If it's less than the degree of the denominator, so this one has none. If it's less than the degree of the denominator, that means the degree of the denominator is bigger. It's going to pull it to 0. So that's your y equals 0. That's what this one's going to be. What's the degree of the numerator here? The degree of the numerator, that's a 3x. You can think of it as x to the 0th power, which is just 1. There's no x there. The degree of the denominator is just 1. That's obviously bigger than 0. So that's why you get a y equals 0. Now, if the degrees are equal, you really can just take the quotient of the two. The two coefficients that on top and bottom, but we don't have one here. We'll have one next. All right, let's look at this one here with, and by the way, I always like to let students know, why are we doing this? Because you can actually sketch graphs quite easily once you become proficient and fluent at breaking these things down. Right, denominator, what do we do? Domain, we set the denominator equals 0. We know x plus 1, well, we set it as a not equal 0, which is to say x not equal to negative 1. And we know at this bad point, you're going to have an asymptote at this vertical line. Now the x-intercept is wherever the numerator is equal to 0. That'll make the whole thing 0, right? No matter what you divide by, if you have a 0 in the numerator, you've got yourself a 0 for the whole thing. So you've got x plus 7 equal 0. That means x is going to equal to, sorry about that, it's negative 7. So x equals negative 7. But of course, you technically should be writing this as a point. All right, I'm okay if you say x equals negative 7, as x-intercept is negative 7. Y-intercept is where x equals 0, and that one's easier because you can just plug in 0 to the function, right? Half of math, I like to say, is plugging in stuff. What's f of 0? Of course, then you have to do it correctly. F of 0 is 0 plus 7. 0 plus 1, well, you just get 7. Okay? Y-intercept is 0, 7. If you want to say 7, I'll kind of accept that. But please remember it's a point with 2 coordinates. Horizontal asymptote we just talked about. If the numerator has a higher power than denominator, it doesn't have a horizontal asymptote. If the denominator has a higher power than the numerator, it's 0. Y equals 0 is the horizontal asymptote. It's always going to be y equals something if there is one. Now they're equal. Essentially what I tell my students, it's just small. You ignore small potatoes. This is end behavior. For big X, the 7 and the 1, if you're a billionaire, you don't care about $1. You drop out of your pocket. It doesn't change anything for you. A billion over a billion is 1, right? X over X is 1. Now, as we move on, I hope that you should be able to do most problems that come up. They look scary sometimes with more numbers in them, but this process works. Now, we're going to talk about average cost, but I want you to understand that's just the total cost divided by the number of miles, right? Whatever you're averaging over. In this case, we're averaging over miles. We have cab or Uber or whatever. You've got to pay for that Uber to get to your house, $4. They don't break it down this way, but if you're running a business, you can't just go to someone's house and drive them 1 block without charging them a fee just to get there. And then every mile you charge $3.50. Kind of expensive, but hey, it's New York maybe. So we don't really need to know all that. If you're given this equation, you don't have to think. You can just do your usual stuff. But I want you to be able to think if you have to. All right, we want horizontal asymptote. We ignore the smaller degrees. We only look at the highest degree in the numerator and the denominator, and we simply take the quotient. 3.5 x over x. Well, the x is, that's 1, so it's just 3.5. Dollars. They don't even tell you the units, right? So if it was dollars, if they told you units, you'd write dollars per mile or whatever, but it could be, pennies per kilometer. I don't know. So you just say 3.5. Now, vertical asymptote here seems pretty clear. You're going to put it at an integer because, we always assume it's at an integer unless there's reasons to not assume that. But you can see 4 is your x equals 4. It's a vertical line. Horizontal asymptote here clearly seems to be y equals 0. All right, now you can always stop if you need to and go back. That's the great thing about video, so please don't mind if I'm racing on here. Review what I'm saying. I'm trying to say exactly the minimum things you need to hear with a little bit of explanations now and then. To simplify this expression, you're basically half of mathematics is substitution. What's f of 4? It's 4 cubed minus 2 times 4 squared. And you can put parentheses around these if you want. I like to do that to remind myself. Plus 7 times 4, but you don't have to do it if you don't want to. Just got to know PEMDAS, right? Do what's in the parentheses first, then do exponents before you multiply. If you multiply 2 times 4 and then square it, you're going to be in trouble there. You don't want to start multiplying until you finish your exponents. So you get 16, negative 2 times 16 there. You've got a 4 times 4 times 4. You can use a calculator. Sorry for that weird 4. And you've got 28 and then negative 12. So, there's different ways to break these things down. That's 32 for me. I just remember certain things. I remember now that's pretty close, so that's like a negative 4, right? These two together make a negative 16. So I've only got a negative 16 and a 64. So I've got 64 minus 16 gives me 48. That's how I do it. I kind of connect all the numbers and just kind of work with each one. Now, divide by any method you prefer. Now, if it's simple like this, if the divisor is just x without 2x or something, you don't have to use long division. You sometimes otherwise would have to. If it was like 7x minus 3, you have to use long division, right? You'd set it up and say x minus 4. If we want to use long division, you can always do that. It's sort of a monkey wrench. You can always figure out a way to make it help a little bit. But that's not how I'm going to do this one. Okay, you would start by saying what? 5x squared times x is 5x cubed. Then you say 5x squared times negative 4 is negative 20x squared, etc., right? That's not the quick and slick way that Mr. Clarkson has, convinced me is always good to know. What you can do is if it's just an x and a number that you're dividing by, you can flip the sign on the number, put that up in the crow's nest or whatever you want to call it, up in the balcony, and put the coefficients. This way you don't have to write any x's. You can just do the same kind of computer calculation without the it's waste of time, basically. You bring down the 5 and you kind of bring it down here and go boom. 4 times 5 multiplied to negative 20. Add these together. Because you flip the sign, you don't have to subtract. You just add. Minus 7. 4 times negative 7 goes up there. Negative 28. 31 minus 28 is positive 3. 4 times positive 3 is 12. 12 minus, or negative 12 plus 12 is 0. And this last thing is always the remainder. Okay? If the remainder is 0, what that means is that polynomial you divided by is actually a factor, and as is the thing that you're about to come up with here. The constant term is always next. After remainder, you work from right to left. The constant term is just plus 3. The next up is the x term. Then there'll be the x squared term. That's how it always works, right? Minus 7x, 5x squared. So we know, because the remainder is 0, we know you can write 5x. Well, I kind of messed that up here. Let me fix that. 5x. Let me fix this here. I'm trying to get a little space. So we have 5x squared minus 7x plus 3 in parentheses. We know, if you know that if you do 12 divided by 3 equals 4, you know that 4 times 3 is 12. If you divide and you get a quotient and there's no remainder, so I can say 5x squared minus 7x plus 3 times x minus 4 equals this big long thing, right? 5x cubed. You don't have to do all this, but I'm just pointing out that this is a really important truth that we have found. Okay, when the remainder is 0, you actually get a factorization. Finally, we'll do a little multiplication here. You know how to do, well, we'll do some couple different ways of multiplying this. I just do kind of a FOIL type thing. I just take the first one, or double distribute, I guess you could say, right? You distribute that everywhere, so you get 2x cubed plus 6x squared minus 8x, and then you also have, for the 9, you've got 9x squared, 9 times 3, and 9 times 3x and 9 times negative 4. So I'll do 9x squared plus 27x minus 36, right? Then you just add them together. Now, and that'll be what? You see how I kind of line up the same coefficients, the same degrees? So you get 6 to 9 is 15, x squared, you get a positive 19, I think, when you take 27 minus 8 is the coefficient of x. And then the 2x cubed just comes down. Now you could also do it by 2x. You split 2x plus 9, the smaller number of terms there, and you just kind of put a box method going, right? You get x squared plus 3x minus 4. So you can do it that way if you want. Factoring, you hopefully are really good with. These all kind of get split, and they all have x's to start with. Okay. The only thing you have to do to start is figure out, okay, what do I do with the signs here? This is a positive 20. The numbers will make positive 20. So I've got to either have a double negative or a double positive. But they're going to add up to positive 9. So they're both positive. 5 and 4 add up to 9. Some people do it this way. They write the the constant there. You kind of call it the x method. You write an x, and in the top of the x you put the number, your constant term, then you put the linear coefficient in the bottom, and you try to figure out factors of 20 that add up to 9, and you just kind of helps you to think about it. But you basically are writing all the factors of 20. 10 times 2, 5 times 4, 20 times 1. All right, similarly, now this is a negative 35, so that means there'll be a positive and a negative, because that's how you get a negative number, right? You have to have one of each sign. And the difference has to be 2, so you can put it, I don't even worry about the signs, I just put 35 and 2 here, and I think, well, 9 times 4 is, no, that's 36. What would it be? 7 times 5, right? Then you have to think, well, the bigger you need the 7 to be negative, because when you add negative 7 plus 5, you'll get negative 2. Okay? Now this is a difference of two squares, x minus 6, x plus 6. I'm not going to say any more about those. You need to know that. You can think of it as plus 0x. If you want to use the same method we've been using, you can still use that method. The difference between the two factors is 0, and it's got different signs because it's a negative constant, but I just memorized that. You have to do that. Now this one is going to be a good practice one, as is that one. I hope this helped.